Hello everyone, I am Maurizio, editor-in-chief of Power Electronics News. I am at Electronica and I have the pleasure to stay here with Alex Lidow, Chief Executive Officer and co-founder of EPC. Hi Alex, how are you?
Hi, Maurizio. Good to be here.
Thank you. So, Electronica, how is going Electronica? Wide band gap, GaN and silicon carbide, we are living a good moment. Where is GaN going?
Well, first of all, electronica is amazing. You know, after 3 years of not being, or 4 years, I guess, since I was here last, it's just amazing the number of people, the vitality. But also, there's a step function difference in wide band gap. 4 years ago, nobody knew anything about it, and now there's a dozen companies showing here and talking about it, and more than 24 companies exhibiting products that include gallium nitride or silicon carbide. So we're really seeing the wave begin.
So we are celebrating 50 years of E Times. So you have a long career in semiconductor, a great one. So what is the most important innovation technology that you have seen during your career that will be important for you during these years?
Well, I think that the most important shift occurred maybe 45 years ago when we went into switching power conversion. By going to switching power conversion, we in essence went from a lossy type of power conversion to lossless. And I think that most people have concluded that between 15 and 30% of our world's energy was saved by that. And you know, I was proud I was involved in the power MOSFET developments, which was the seminal element that allowed efficient and economical switching power conversion.
Thank you. So during your career, what what challenges you have faced most, and how did you overcome it, and what did you learn from it?
So my whole career, I've been in companies that were very small, competing against huge established companies with a different technology. So with the power MOSFET, we were up against Motorola, which had an 80% market share at the time. It was the biggest semiconductor company in the world. And then we had all the Japanese companies, and they were all competing against this little tiny company, International Rectifier. So I've actually, developed an enjoyment of being the David versus the Goliath, and constantly moving a little bit faster, so that it's hard for the big giants to turn and twist as fast as we do. And it's happening again, with GaN against Infineon. It's a huge giant corporation again. But I enjoy it.
So let's think to travel in time, challenging the Einstein theory. So like Back to the Future movie. So if you have this opportunity, future, past, what would you do?
So you're asking what I would do differently than in the past?
Yeah, if you like to visit the future, the past, why? So let's think that you have this opportunity.
Well, I always like to go to the future. I mean, the past is the past, and I don't want to deal with that anymore. But in the future, I really want to see the deployment of gallium nitride in some very wide-ranging energy savings applications. And we've estimated that maybe we can save another 10% of the world's energy with gallium nitride, and it's just such a fun journey. I can't think of anywhere else I'd rather be.
So we are living a good moment in GaN also thanks to the great job that the entire industry, you and others leaders did in particular. So what are the next challenges that industry should face just for arriving in a good adoption in terms of GaN, but also other? In general, what are the next challenges for our industry?
So I think that many people think about the power semiconductor industry as going through a new renaissance because of wide band gap, and I would agree with that. Below 650 volts, that's where the MOSFET is dominant. That'll be written over by gallium nitride. Above that is silicon carbide, which is writing over IGBTs. And it'll take a long time before those silicon devices are dead, but they're probably in legacy mode now. What are the barriers? One of the biggest barriers is talent. Engineers that are able to deal at higher frequencies, at higher power densities. There's more thermal management. There's tighter layouts. There's higher frequencies that use that have EMI issues, and that talent is not yet coming out of universities in enough quantities to lubricate the entire adoption of wide bandgap.
So electronica indeed is famous. I mean, because there are a lot of young people that are coming for finding inspiration. So, for experience, I found my inspiration a couple of years ago at electronica. So, what is from your career, long career? What is your advice for these people? Maybe starting a particular university career for specific topics. Maybe I know that in terms of university and companies, we need also to reduce the gap, the mismatching, maybe academic and industry. But what is your advice for young people, professionals?
So I think that there are two big dynamics right now. Over the last 10 years, the field of engineering has been stripped of talent going towards computer science. They all want to be, autonomous vehicle and robotic designers, sit at a keyboard and design. And now there's an undersupply of electrical engineers that really understand how to design a circuit or build something. So I think that for a new person coming out or just deciding on their career, to get into those areas where there's a scarcity is a good idea. And then to get into those areas where there's a scarcity and a sea change occurring in the industry is a combination of two good ideas, and that's good for your future. So wide bandgap and real hardcore electrical engineering as opposed to computer science is a beautiful career path right now.
Thank you, Alex. Thanks a lot for this interview, this great experience. Always a pleasure to talk with you. Thank you so much.
Thank you.